Okay, so the first thing we're going to do now is to install Pandas, and that is done by installing Python first, then add Python to your path, then come to the terminal and write pip install Pandas. Hit the enter button, let it run, we'll be back. Okay, as you can see, Pandas is satisfied on my computer already. The requirements are satisfied on my computer, so let's go back to VS Code. So the first thing I'm going to do now is to import Pandas. I'm importing Pandas as PD. So in Pandas, we have two types of data types, series and data frame. Series are actually one-dimensional arrays that can store any kind of data type in Pandas. So first of all, here we have H. H is a set in Python. You have different kind of data types that are not repeatable. You have different types of data with not repeatable value in a set. So that's what we have here. To convert that to a series, you have to do pd.series of it. When we run that, you get the Pandas series. So you can also display S here, and S tells us that our index from 0 to 3 and our values are what we have in this series. So Pandas automatically generated an index for us from 0, 1 to 3 and give them the values of our set in H. Okay, we can also convert a dict, which is a dictionary in Python, to a series. And here the dict we have is of key value pairs, obviously. Then you have name, IBM, date, 2010, shares, 100, price, 10.2. Converting from a dictionary to series, pd.series of D. And then if we print D, we get this. Then if we print ds, we get this. So here, reference to what we did before, Pandas automatically generated our indexes, but here it's used the index, which is our keys of our dictionary, as our series index. So checking the type of ds here, we have a Pandas series, which is good. Okay, so next we have an array. We can also make an array a series, and also here we are giving it an index manually. We don't want Pandas to give us its own index, so we can first do that by specifying the index value in our series, and then giving it the same length of data in the array we have. So printing that out, we get our index here as this, then our values as our main array. So we can also extract a particular row from our series, and that is done by using the square brackets. Then in the square bracket, you put what you want to extract. So here we're extracting percentages. If you run that, we get 3.2, which is what we have here. So here you can also extract 2 rows from your initial series. That is done by the same thing we did before, but here we're putting this in an inner bracket because of is a single series. Then if you run that, you get name and percentage. You can also add amount if you want to. You can come here and add the amount column. If you run that, we also get amount out, which is 90. Also in Pandas, there's what we call data frame, which is a two-dimensional array that stores rows and columns. Here we have a dictionary of key value pairs, like before, just of some random things like name, shares, price, color. Run that, take the type of our data, which is a dictionary. If you print the data out, you see how it comes out. It comes out in the dictionary form, but then we can also convert this thing to a Pandas data frame. Now done by saying our df, which is our variable, is equals to pd.dataframe of our data. We now take data argument to be our data, which is dictionary. Then if we were to print this out, we get that a very nice looking data frame. Then we'll take the type of our data frame. We see that is a Pandas core data frame. So you may also want to add a column to a data frame, and that can be easily done by saying df in brackets the column with a string value of the column name at the header, Then you now give the array of the values you want to add to the column. If you now run that, you can give us something like this. You can see the size was added to the end of the data frame. So you can also add a single digit that will span across all the rows of your column. You can also do that by saying df in square bracket, also the string you want to add, then the word you want to span across. And if you run this now, you look at how it comes out. It comes out with age, new column, then now gives us nans all through rows. You can also add indexes to our data frames. So here you can see Pandas give us an automatically generated index from 0 to 2. And we don't really like that. We want to make our own customized indexes. So you can do that by adding df.index 1, 2, 3 and the same length as our rows. Then we now run this cell, gives us a better looking index than Pandas gave us. So we can also extract a column from there. The same way we extracted a row from our series, we can also extract a column from our data frame, and that's done by doing the same example, but putting the square bracket and putting the column we want to extract inside the square bracket. If we run this cell, it gives us our shares 10, 13, and 12 with our indexes ahead. So now Pandas was smart enough to know that we already have an index. It only gives us the shares column together with our index, and that's fine. So since we're talking about columns, we can do the same thing for rows. So extracting a single row, if you want to extract the row that is on 1, which is Jim, 10, 200, blue, big, and none, you can do that by using the lock. And if you look at the documentation here, it says access a group of row and column by label or Boolean array. So we can use this to access single rows. So we do that by doing df.lock then 1. So this will print out Jim, 10, 200, blue, big, and none. Run the cell, you get that. Next up, we can also select all the rows in a column. So if you have this column or this column, and select all the rows in that column. You can also use the lock keyword. So now what lock keyword takes is a row and column. So we are doing all, which is by this column, then all the rows for column of shares. So looking at this, it was row 1, row 2, and row 3 for the column of shares. Let's run that and find out. So it gave us the same thing. Similarly, we can also do that for columns in a row. So looking at this now, we can see that we have different columns. But now I want to get all the columns in a particular row. So I want to get this column, this column, this column, this column in this one row, which we've done before, but we can also do that with the lock keyword. So now, remember when I said lock has the row column format? So the row of 1, then column all. So this semicolon here shows us that we want to get all the columns, while this one shows us that we want to get all the rows. Running this gives us this, which is like what we did here before, just to give you a hint. So we can also delete a column in our data frame, and that's done by doing del df of the column we want to delete, which is h in this case. Running that, then printing df again, we see that we now have the h column again, rather than what we have here of each of all non-values. So now we have the h again. Also, you can do that with our drop keyword of the data frame. So we'll specify the column we want to delete with shares, and in our axis. So axis of 1 is column, axis 0 is row. So axis of 1 deleting our column, run that, it takes away shares column. And then if we want to delete our row, we do axis of 0, and then we run that, it deletes the row 2. So in Pandas also, you can read files. Also, I've gotten a test file here, which is cast.csv, which we're going to be working with today. So let's basically read the file. So in Pandas, we read file identity pd.read csv of cast and specify that our index column is none. And then we print cast.head. So cast.head gives us the first five rows of our data. Well, also we can specify an argument of 3, gives us the first 3 rows of our data. And then we can also use tail. Here I've imported another CSV file. And also if you get an error, you can encode it with UTF-8, and that's by passing in another argument of index. Here you can also use .tails. Tails will give us the last 5 elements of the data frame. So here I've imported or I've read a CSV file titles.csv and named it titles. So if we get titles.tails, we get the last 5 elements of the data frame. We can take the length of the titles. You can see it's 5,000. So length gives us the total amount of rows we have in our data. Now we're going into some data operations. If you select the row column in our titles and name it a variable, and we can check the type of the variable that is, we see that is a Pandas series. A Pandas series, remember, is a one-dimensional. So we are getting the title alone from this makes it a series which is one-dimensional. So getting the head, that means getting the first 5. You get it also. Pandas indexes our series for us arbitrary. Then we get the first 5 elements in our series. When filtering the data, we can also filter data in Pandas. So we want to get the movies that after 1985. So in our titles, we have a lot of movies, and also you have the years they were brought out. So you can do that by saying after 85 titles, title year greater than titles, then in brackets our column, which is our year column, when is greater than 1985. So this will give us all the movie titles that are after 1985. Then getting that, you can see what it gave us. Also, if you want to confirm, you can check the after 85.tail, and you see also it is greater than 1985, all of them. So moving down to display the movies in the year 1990 to 1999. So we'll do that by calling our T titles, which is what we have here, our titles read from title.csv. Now when we do that, we say we give you some conditional statements. You say title column of the year when it's greater than or equal to 1990, and when it is also less than 2000, and include that all the in your brackets of T, and we call that movies 90. If you do that now, notice we didn't specify heads or tail, so it gave us the first 5 of our randomly selected heads and then the last 5 randomly selected tails. Wow. Sorting can be done also in Pandas. So if you want to sort and find out the movies named as Macbeth, so if you want to print out T, this is T. So we want to get all the movies named Macbeth in the title range. So we say the title equals to the string Macbeth. We should bring it out. So we check that and we get it. So if you want to also check the length, you see length of Macbeth, and also print out it for us. So we only have 5. So if you run this cell again, you get all the 5. So we can also sort by index the values of our Macbeth. So in Pandas, the default sort is always by our index, which is these values. It is these values here, these ones. That's our index. So if we're sorting by our index, we can use the keyword macbeth.sort index with a function. We call the function on this object. So that gives us our sorted macbeth data frame. And also we can sort values by particular column, which is, for example, you are doing it by year. Sorting values by year column, we want to rearrange these values according to their years from the smallest year to the largest year. We do that by macbeth.sort values year. Run that, it gives us into a nice format. That's all for the title.csv. So going to our cast.csv, we see our cast has also titles, years, names of people, type, the character, and also this end value. I'm not really sure what this is about. So we can see also that our cast has 75,000 rows approximately and 6 columns. In this end column, we can see that we have some non values here, and some non values are not what we want to see in our data. So we cast here, and then we want to get where all n are null. Basically, you have any n on them, that means null. So you can do that by saying cast in square bracket the end column dot is null, and that gives us all the places that none will have true, and then all places that have values will have false. I may be wondering whether this is only for numerical column, and we can try that out by checking title. Title works because you see false for all of them, meaning that there are no places in title that have null values. Well, if I want to go ahead further and get the data for where the end values are none, just have to enclose this whole thing here in a square bracket and then put C, which is our cast. So while doing that and getting the data of all of C, where the C itself having the end column is null. So guess what this is going to give us? It's going to give us the whole data or the whole rows where end is none. So in running that, it gives us that. So we can also check the length of everything here, and we go back and type len, closing everything in that bracket, and gives us 5. So that's how you work it out. So then with these non values, you can also fill them up with stuff. Let's X that first. And 1. So all these non values, we can also fill them up with values of our choices. But there's a method in Pandas called fill NA. Also a method called ffill and bfill. Ffill and bfill means forward fill and backward fill. So what this does, what this we are going to do is, for example, if you have NaN, forward fill is going to fill 10 up 10 in this NaN, this one also, and continue filling up until it reaches a digit, it stops. Then that digit continues and fills this NaN, it reaches the digit, it also stops, and this one fills this NaN. But backward fill goes backwards from the name. It starts from down, fills 25 upwards until you see the digits, it now stops. This one continues and fills this digit, it stops when it sees this digit. Then this one fills up until it sees another digit, it stops. But then fill NA basically is a filling for everything no matter the sequence. So I'm passing a variable cfill into this our previous call, which is giving us the rules for our null values. I'm passing that with the function of dot fill NA, giving it an argument of NA. So what's going to happen is that you need to fill all these places we have NaN with this NA. So if you run that, it fills all of them with NA. So going to string operations, we can also get a particular movie, but the title is MAA inside. So the same way we did for the is null function, we can do that. Sorry, same way we did for the C indexing for the cast. Same way we did previously, we can do that here. So if you take the column of T equals to MAA, so basically what I'm doing there is in this column, this titles column, where equals to MAA, we want to take that out. I'm setting for that. So running this cell, it brings out the particular place where this occurred. We can also change it, but let's try boom. So when we copy that here, I will run that cell. We can also try this. So when I copy that there, and run this cell. Now also you can do that also for all the values, for all the strings in title that starts with MAA. So we do that by doing .str or starts with MAA .head. But remove the .head for a moment. Running the cell gives us all the values that starts with MAA. So we have MAA, Durga, Scotty, Barikop, all of them. So let's keep back the .head, even though the 5 first values we want. Maybe also want you how to get number of years for each year in data frame. So that is done by 10 years .values count .head. So values count gives us the number of values in our year column. So now it tells us that 2016 has 2,363 appearances, 2017 2,138, and so on. In this, you can also check for the type, how many actors and how many actresses, by using the same value count. So run that cell, it tells us that actors are 50,000 actors, and also actresses are 25,000 approximately. So I also want to merge data in Pandas. So here I have a sample data of release dates of CSV containing release date of movies. So when we run that, we check the data, we see that the has title, year, country, and a date, which is dates for the release, which is the release date of the movies. So forecast where the title is Amelia. So we run that to get this. I want to get our release title where is Amelia also. Run that we get this. So now we can merge these two together. Now a condition for merge is very simple. Sorry, let's reduce it by adding .head. Run that again, we get this small value. So basically for merge, you have to make sure that a particular column is the same. So here we have our title, same with the title here, and all the values there are Amelia. So if we merge that, it merges safely. So what it does is it adds the two columns of C Amelia, which is title and year, with the two columns of release, which is title and year, and it merges them together to get this large data frame. Also, you can specify explicitly where you want to merge. So with that, we're going to get an example from cast where the name is Aaron Abrams, which is that, and also want to merge C with cast on title and year. So you can see what happens here. It merges on a particular condition. Now here we're going to merge cast on the condition, but also I want to say where name underscore y, which is here, is not equals to Aaron. Sorry, is not equals to Aaron Abrams. So we do that, but here you can see it has created all the Aaron Abrams name underscore y. So going into NumPy, the first thing before we import here is to install NumPy. Say pip install NumPy. And you can see I already satisfied the requirement. So let's go back and continue. So we did that. First thing we do is to import NumPy, and importing it as NP, basically community standard. In NumPy, we have what we call 1D arrays. So you can specify, you can do that by saying np.array of, in brackets, you put a square bracket of the array you want to make. So when we do that, and we run this, and we run the, you see it gives us an array. Now when you check the type, is a NumPy ND array. So basically an n-dimensional array, which is the one-dimensional array in our case, because it's one-dimensional. But for a multi-dimensional array, you can specify that by having the same np.array, but then in your circle bracket or your normal brackets, you put a bigger bracket and specify other dimensions of your array. So to make this more visible, I can do this. So now you can see we have 1, 2, and 3, kind of like a matrix form, but then it's multi-dimensional array in NumPy. So if you print this out, if we run this first, then print this out, you get this. But then if you now check the type, you see it's an ND array, which is basically an n-dimensional array in NumPy, multi-dimensional in our scenario. So we can check the shape of the array by doing np nd.shape. Run that, you can see the 3 by 3. Basically, I told you it was like a matrix form, but now it's in NumPy array. So in matrix, we have row column arrangement. So if you were to be matrix, this will be row column. Same thing with NumPy. So we have 3 rows, then 3 columns also. So we can check the type of the ND array. We see that is an int32, which is basically the smallest for NumPy in Python. We can create a 0 matrix in NumPy by doing np.zeros of 3. So what that does is basically going to give us an n-dimensional array, basically one-dimensional array of 3 zeros. But then if you specify another argument, which is 3, 3, we get another thing, which is connect updated type. But then if we now enclose this in a circular bracket and we run it, it gives us a 3 by 3 matrix, which is telling us that it's giving us a multi-dimensional array. Then checking the type of np. We just specify this as a variable. Let's call this n. Run that. Checking type of n. Yours in NumPy ND array. So it's an array of NumPy. We can also create a dimensional matrix. That is done by the np.i. And dimensional matrix is basically what we know in our matrix from high school as identity matrix. So if we do np.i of 3, it gives us a 3 by 3 matrix of ones in diagonal form. I'm sure some of you are familiar with this from high school. So you can also add numbers to our matrix, and we do that by basically arithmetics. If you say e2 equals to e plus 2, you get to add 2 to all the numbers in our matrix, which is also an NumPy ND array. So we do that, we run e2. So it added 2 to all the numbers in our matrix. So if you want to create matrix with all entries as 1, basically making everything here 1, but then the size of e2, and e2 is a 3 by 3 matrix, we can do that by doing np.ones like e2, and then running that to create a matrix of ones but making the size of e2. And taking the type of o, you see that is a float 62. We can also convert that to an int32 by saying o as type np.int32. And also the same thing, but if you check the data type, it's int. So we can also convert that to a 64 too, if I'm not mistaken. So another thing you can do with NumPy is initialize random numbers. So first of all, we're going to create a random array of 5 by 3, which is basically 5 rows by 3 columns, and given that is done by np.random.rand n of 5 by 3. So also we can also have a condition. If we initialize this name equals to that, we now want to check where name is equals to a particular string in our NumPy array. We can see name equals to a string, then it gives us a true and false notation in our array, telling us that it's true that A is equals to A in the first, but it's false in the second, it's false in the third, it's true in the fourth, and it's false in the fifth. We can also create an array of lengths, of any length you think of in NumPy. That's done by using np.arange or arrange, depending on how you call it, from starting point of 0, ending point at 20 exclusive, meaning that it's not adding 20. So to recap here, we're talking about the starting point of 0. Then if you run that and then print A out, it gives us 0 to 19. You can also initialize some step values. Let's say if you have 2, you can give us all odd numbers, all even numbers from 0 to 18, 20 exclusive. So here is our start, stop, and step. We can also reshape this array. So if we want to now make it a 4 by 5, that means everything here, which is basically, if you check the type, let's say type A, we'll see that it's a NumPy ND array. If you now check the size, if you now check the shape, A.shape is a 10 by nothing. Basically is a one-dimensional, all rows. Now reshaping that into a 4 by 5. Let's see what it's going to give us. So it cannot reshape that into 4 by 5 because of something is not correct. This is 4 rows by 5 columns, which are meant to have 20 values, but here we have 18 values. So we can also change this to a 5 by 2. Then if we now print that out, it gives us 2 columns but 5 rows. So now if we want to select the particular row from the array, the 5 by 2 array we made just now, we can do that by specifying the columns we want to get, and I put that in a square bracket inside another square bracket. So if you now print this out, it's going to give us row 2. Remember, Python starts counting from 0. So this 0, this 1, this row 2, then it gets to row 0, and it gets to row 1. We can also transpose B. And transposing B is basically making this from a 3 by 2 to a 2 by 3. If you now check B.shape, sorry, I'm not mistake, it must be B.shape is a 3 by 2. Concatenation. You can also concatenate in NumPy. First of all, we initialize an array of range 12, basically 12 digits, then shipping that to a 4 by 3, and we have also another array of random values in 3, 4 matrix form. We run this, gives us ARR gives us an array of 12 numbers in the shaped form of 3 by 4, and RN gives us a random 3 by 4 matrix. In concatenating them, you have to make sure that your row number are the same. As concatenating that gives us something like this. So now what happened here is that it added them on top each other. But you can also specify that I want to do it in axis of 1, which is adding them column wise. What happened there was row wise. So adding them column wise gives us something like this. So you can see it started with 0 to 11. That's 0 to 11. Then I started adding the others after them. So now this, guys, is the end of this chapter. You can find all the code in my GitHub. The link will be in the description. See you next time.